Hello guys, this is Andre from Packet Networking blog. In my previous video, I built a couple of VM access and established some interconnections and management access to them. And I was thinking, how can I extend this topology to do something more complex? And for this purpose, I decided to create a couple of route reflectors. And as a platform for route reflectors, I decided to use Juniper containers RPD, cRPD product. And the idea to do something like that, so existed VM access, there will be IBGP clients, and my new containers will be route reflectors with a direct IBGP connection between them. So first of all, let's discuss what is cRPD actually is. So Juniper routing protocol process, RPD, is usually part of JUNAS. Is one of the processes. It's responsible for all related to the routing. So it's storing routing information, calculating path paths after applying some policies, and also propagating this information into a forwarding information base. So in case of cRPD, RPD isolated in a container, it's not alone. It also couples with CLI and management processes to interact with container, and also has directional forwarding detection and PPMD dedicated processes to exchange some routing information and BFD control packets. So instead of ASICs, FIB is installed in the Linux kernel. Netlink helps with a couple of things. So first of all, it's installing active routes into the kernel, into the FIB. And the second, it helps with exchanging control packets for some protocols like BFD, or other like BGP and so on. So it helps with the interaction between the user-defined container and the kernel itself. cRPD use cases. So Juniper provides 3 off-the-box use cases for this product and 1 on-the-box. So in my understanding, off-the-box use cases related to Linux server hardware, and on-the-box it's some network hardware. It's open source Sonic enabled network hardware where the cRPD can be installed. So from the Linux server perspective, it could be a host-based routing use case when you establish layer 3 functionality with the cRPD that's installing this component. It also could be BGP egress peer engineering, where this cRPD product can interact with the controller and instruct peers how to steer traffic, how to transmit traffic through the BGP network. And also it could be a route reflector functionality when cRPD can be just BGP route reflector and reflecting BGP routes from multiple BGP families. In my case, I will try it as a route reflector, and if you check the scaling, it's pretty impressive. So we can reach up to 200 million routes if we allocate 64 gigabit to it. But for lab usage, 256 should be okay. Okay, so what I'm actually going to do, let's check this structural diagram. All on the right I already established in my previous blog and described that. So it's a couple of VM access connected, interconnected by G000 through VM9, VMWARE Workstation bridge, and also I have remote access to them. So all the part on the left will be totally new. So as you know, cRPD can be managed by Docker or Kubernetes. I use Docker in my setup, so I'm installing Ubuntu with the Docker, and Juniper recommends Ubuntu 18 for this setup. So I'm installing that. I will create a couple of cRPD instances on the Docker, and to connect them to each other and to VM access, I will use Open vSwitch product for that. One of the switches will be for direct interconnection, and another one will be connected to Ubuntu ENS interface in promiscuous mode, and I will attach this interface to VM10 into VMware, and both VM access will be also attached to this bridge. And this way I will connect G001 interfaces, both of them to both all the containers. So let me start the installation process. I downloaded Ubuntu 18.04 server install image, this one, and also cRPD evaluation version from the Juniper website. Put it all into my folder here. So let's create the Ubuntu VM first. So I do new virtual machine. Ubuntu username user, some password. Okay, Ubuntu 18, 1 core, 2 cores. I will assign 2 GB of memory. Net is fine. This is default. Create new virtual disk. I will store it in a single file. Okay, next. Okay, here the first adapter we'll use to allow this VM to access internet and to access VM itself. And the second one I need to put into bridge in VM10 to get connectivity between VM access and my Docker containers, as I told you before. And also, it's pretty important that I need to enable virtualization, and virtualization inside virtualization to make Docker containers working. Okay, close that, finish. English, develop updates, my proxy, tie disk, done, continue. User, creating a password here. Yeah, we need to install OpenSSH. Done. So there is an option to install Docker from this menu, but I would better to install the newest version from the instruction from the website. I'll show you later. Okay, guys, our Ubuntu VM is up. I'm logging into it. Let me check interfaces. It's only one is added, and address 88.132. Okay, let me connect into it. 132. So I have some basic stuff to do. Set up a password for root user, update packages. Okay. SSH is already installed. So next thing, I need to install Docker Engine. So you can check on this link. So I update package. Yes. Adding GPC key. Okay, done. Checking fingerprint. Okay. Set up repository. Installing Docker itself. Yes. And adding user to the Docker group. Okay, it looks like it's installed. We can do run hello world just to check it's working. Docker images. Okay, images here. Now we need to upload our cRPD Docker image. Then I need to load it into the Docker repository, Docker load. Okay, takes some time. Now for cRPD, I need to create the volumes. It's like storage space dedicated for these containers. So it's one for configuration, other for warlock directory for 2 containers. And next I need to just spin them up. So if we try, you see this is our cRPD image, so I put it here with the tag. So I put restart unless stop, so it will be restarted automatically. I put some console info, and also allocated the lowest amount of memory possible, 256. Okay, first one, second one. Okay, they both up. And if we check stats, we see that mem usage 256 allocated. It's like 40% of memory is used and very little CPU time. The next part of configuration is the networking part. So if you check current Linux interfaces state, So just only one ENS34 management interface is up, but our goal is to have two interfaces, and ENS33 should be used in promiscuous mode, as I showed here, to link our containers to the Juniper VM access. So we need to bring this interface up and make it promiscuous. To do that, in Ubuntu 18, they implemented new concept of a net plan. So all the networking configuration defined in YAML file under etc net plan. So if we check now, it shows by default that only ENS34 management interface is defined. So we need to put 33 here. So it's better to delete everything and put our part here. Okay, so you see ENS33 DHCP no. We don't need any IP address on it. So save, yes. After that, we need netplan to generate this configuration. Okay, it's good. And to set up promiscuous mode, we need to do it through the scripting under the network dispatcher directory. So by default, it's nothing in it. So we need to create new script, shell script. And in this script, I just put this command to make this interface promiscuous. Okay, that's basically it. And also I need to add execute permission to this file. Sorry, sudo. That's it, and restart networking process. And now if we check our interfaces config, we see that ENS33 is up and it's in promiscuous mode, exactly what we need to do. And this configuration, it sustains reboot. You can check it later. Okay, now when all the VM ports are up, we can go to the next step. It's creating Docker bridges using Open vSwitch for that. So it's pretty straightforward to configure it. I have some script defined, so I'm adding a couple of bridges, peer-to-peer bridge for point-to-point connection and BGP bridge to connect to VM access. So after adding this bridge, I defined and attached a couple of interfaces to our containers, and also I assigned some IP addresses for these interfaces. The same is here, and also I assign interface addresses for cRPD loopbacks to establish BGP sessions later. And if you see, I do all these commands through the script, shell script, and I put the script into cron to execute it just after reboot. Define this file. All this stuff. Saving it. I also need to make it executable. Okay. Defining cron tab from the root user perspective. And here, so just simple configuration. So after reboot, I want to wait for some time until networking will be initialized and execute this script and put the execution log into the cron log. Okay, that's probably it. So for now, I can just execute the script from the shell. Oh, sorry, I forgot to install virtual bridge itself. Open vSwitch. Okay, it's installed. Run the script again. And now, if we check this Open vSwitch state, we see that a couple of bridges were created and some ports with some random IDs assigned to these bridges. So these ports, they correspond to our Docker containers interfaces. So let me show you how to check that. We check config now. So we see that Ethernet 0 is a management address of the container from the Docker 0 bridge subnet. Ethernet 1, this is peer-to-peer. Ethernet 3, this is our bridge for connecting with VM access. It doesn't show loopback here, but if we go to the CLI, so actual Juniper's CLI, and do show interface routing, you see the same IPs assigned and also our new loopback 0. The same story with the second one. If we go to the CLI, you see this IP is assigned, and our peer-to-peer connection between containers should be actually up. So you cannot ping from the CLI, as you see. We need to go to the shell. Okay, we can reach our peer container. This is good. Okay, now when networking is working fine, we can configure our containers. We can go to the CLI directly. So if you remember, we want to configure IBGP route reflectors, and I set up some cluster ID for them and put 2 neighbors, our VMXs, and also establish direct session between route reflector and use OSPF, the IGP protocol, to exchange loopback addresses for the session establishing. So this configuration for the first container. And let's configure the next one. Okay, let's check OSPF neighbors. It takes some time to establish this neighborship. And they can reach each other through the port interfaces, so 2 sessions actually up OSPF neighbors. And if we check BGP state now, show BGP summary, you see it shows license failure, so BGP feature requires a license. License itself, we can download it from a cRPD free trial page, step 2, retrieve license key. If you just open it, you see the license key. Just copy it and do request system license at terminal. Control D, and that's it. So BGP summary, and we do the same on the first one. We can use the same license, request system license at terminal. Okay. And now you see that connection already established with the second RPD container. So next step, we need to activate all the VMX's VMs and configure them on all the 4 VMs, 2 for each VMX. If we look at the diagram again, so these VMXs should be route reflector clients to our route reflector and advertise some static routes I configured. So to have connection to the route reflector, I put the third interface on VMware attached to VFP VMs and put them into VMnet 10 bridge. So if we check the settings, it's adapter for VMnet 10 here. I already configured them. So if we check show configuration, you see that OSPF is configured, BGP with the export policy to export 1 static route. If we check show BGP summary, we see that both session actually established, and it received 1 route from the VMX2 already, show route protocol BGP. Since I already configured VMX2, so you see this route was advertised. And the same station with the VMX2 show route protocol BGP. So it was able to receive the route from that guy. If we check cRPD, our route reflector, see that all BGP sessions are up. It received 1 route from each of the clients, and it advertised 2 routes to its peer BGP. Only one step here is to check if our cRPD, our container, they can sustain reboot, and they can obtain their configuration and all the BGP sessions after the VM reboot. So let me do this. So shut down -R now. Okay. Okay. So let's check interface states. NF33 is up in promiscuous mode. Okay, it's fine. And containers, yeah, both are up. Let's connect to one of the container CLI. So all configuration is there. All the connections are established. Nice. Let's check the second one. Okay, guys, it's all up. It's working. Thank you for the watching. Goodbye.